Do you know Poisson distribution is limiting case of binomial distribution? Yes, you are absolutely true. Poisson distribution is a limiting case of binomial distribution. Why Poisson distribution is limiting case of binomial distribution? Let's see here. To understand, first of all, we remember binomial distribution, probability mass function formula and its properties. The probability mass function formula in binomial distribution is P of capital X is equal to small x is equal to NCX P power x Q power n minus x, where x from 0, 1, 2 and so on n. Where it applicable, binomial distribution is applicable only when the first property is number of trials of an experiment should be finite. That is, trials may be 0, 1, 2 and so on n. The second property is probability of success small p in each trial is same. In every trial, probability of success should be same. These are the main properties of binomial distribution. Now let's see Poisson distribution, probability mass function formula. Where it applicable means what are the properties. The probability mass function in Poisson distribution is P of capital X is equal to small x is equal to e power minus lambda into lambda power x by x factorial, where x from 0, 1, 2 and so on up to infinity. Where it applicable, Poisson distribution is applicable only with the properties only. That is, the first property is number of trials is infinite. That is, number of trials approaches to infinity. The second property is probability of success P in each case approaches to 0. That is, probability of success in each trial is not same or constant. Now the third property is product of number of trials n and the probability of success p should be finite. That finite value can be taken as lambda. Okay. Now here we are going to look how Poisson distribution is a limiting case of binomial distribution. Remember, the PMF of binomial distribution is equation 1. Since NP is equals to lambda in Poisson distribution, from that p value is lambda by n and q value is 1 minus p. It is also equals to 1 minus lambda by n. This is the p value and this is the q value. Substitute pq values in equation 1. Then equation 1 implies NCX p value is lambda by n whole power x. Q value is 1 minus lambda by n whole power n minus x. NCX value can be evaluated by using NCR formula, n factorial by n minus x factorial into x factorial, because here r value is x, into lambda by n whole power x. Now we separate n minus x here. 1 minus lambda by n whole power n into 1 minus lambda by n whole power minus x. Now n factorial. What is n factorial formula? N minus 0 into n minus 1 into n minus 2 into and so on, n minus x minus 1th term into n minus x factorial by n minus x factorial into x factorial into lambda by n whole power x into 1 minus lambda by n whole power n. Here the power value is minus, so we should remove by writing this value in denominator. Now n minus x factorial, n minus x factorial cancelled out. The remaining terms in the numerators are n minus 1, n minus 2 and so on, n minus x minus 1 means x terms are there. Why? N is the first term, n minus 1 is the second term and so on. N minus x minus 1 is the x term only. So common n from the x terms here. So we have n power x. Now the first term is n 1 minus 1 by n into 1 minus 2 by n into and so on 1 minus x minus 1 by n, because n is common from each term out of x terms. The denominator term is x factorial into 1 minus lambda by n here, not x here, whole power x, into separate power value x to the numerator and denominator. N power x both are cancelled here. Now apply n tends to infinity to the above value, then the given PMF can be written as limit n approaches to infinity, p of x is equal to small x is equals to, now write infinity value in place of n in each term. 1 minus 1 by infinity, 1 minus 2 by infinity and so on, 1 minus x minus 1 by infinity by x factorial into 1 minus lambda by infinity whole power x into lambda power x, here 1 minus lambda by n whole power n. Apply limit n tends to infinity here, 1 minus lambda by n whole power n. Observe this value is equals to 1 minus 1 by infinity value is always 0, anything by infinity is 0, 1 minus 0 and so on, 1 minus 0 by x factorial into 1 minus anything by infinity is 0 also, 0 power x, 1 minus 0 power x into lambda power x. We have the fixed formula for this limit value in the lower class, that is e power minus lambda. Limit n approaches to infinity, 1 minus lambda by n whole power n is e power minus lambda. So that's why 1 minus 0 in numerator is there. So 1 into 1 into and so on. Lambda power x into e power lambda minus lambda by x factorial. 1 minus 0 whole power x means 1 power x. So it should be 1. That is equals to e power minus lambda into lambda power x by x factorial. Therefore, so p of x is equal to small x is equals to e power minus lambda into lambda power x by x factorial when n approaches to infinity in binomial distribution. This is the probability mass function formula in Poisson distribution. That's why it is the limiting case of binomial distribution.